Hello everyone, welcome back. In this video, we are going to continue our conversation about finding zeros of polynomial. And today we are going to introduce the very last type of factoring, which is called factoring by grouping. Let's check the examples we're going to study today. The first example is x to the third minus 3x squared plus 4x minus 12. And as you can see, instead of we have 2 terms or 3 terms in the previous videos, now we have 4 terms here. So like the way we did before, let's set up equation first. Since we're finding 0, we just set up as equal to 0. So the key word for this is factoring by grouping, which means we are going to separate these 4 terms here by as 2 groups here. So first, I'm going to use the first 2 terms as one group, and then the second one will be the other group. And we all use different color to demonstrate what we do for each one. So for each group, we are going to use GCF for each group. So for this one, the first one, x to the third minus 3x squared, they both have factor as x squared. So I just take x squared out of this, and the rest part will be x minus 3. And second part, I do the same thing, but since they have 4x minus 12, so I know the greatest common factor is only 4 as a number, so the rest part is x minus 3. And if you pay special attention, you will notice now they have both greatest common factor as x minus 3, so I take x minus 3 out of this. And then I just keep x squared plus 4. So the other way to think about this is x minus 3 and x minus 3 take it out, right? What's left? So the first part is x squared and the rest part is plus 4. And reversely, if you use this distributive property, you can think is x squared times x minus 3 and 4 times x minus 3, right? So, and if you remember something we did before, this part we can continue factor by using plus 2i and minus 2i. And I just copy down this part equal to 0. So now we have 3 solutions. You can set up like this way, equal to 0, this one equal to 0, or x minus 3 equal to 0. So we have negative 2i, and 2i or 3. So for each part, for this part, I want to pause here to give you some a different idea here. Some student might think, can I just stop here to solve equation? Yes, you can. Because zero product telling us if you multiply 2 part equal to 0, each part is 0. So for this one, instead of factoring this, you can just solve this equation using this way. So x squared plus 4 equals 0, so I minus 4 for 2 sides, then x squared equal to negative 4. Now I'm going to use a square root for both sides, but remember, when you take a square root by using this equation, you want to set up as plus or minus, so x is plus or minus square root of 4, which is plus or minus 4, and square root of negative 1, so which is plus or minus 2i. And as you can see here, this is just, circle out as a side notes. So the solution is positive 2i, negative 2i, and do not forget, we also have 3 here. So it really doesn't matter which way you use. This actually we consider as factor completely in complex number. So if you get used to this format, you want to separate this one, fine. But if you prefer to solve this way, this is much easier for you to understand. Go for it too. Okay, let's check another example. This one, again, we have 4 terms here, so I'm going to separate that as 2 groups. The first one is first group, and the second one is second group. And do not forget, we are solving this as equal to 0. So do not forget each part we use GCF. So first one, they both have m squared, so I take m squared out of this, and the next part is going to be m squared plus 9, because m squared times m squared is m to the 4th, m squared times 9 is 9m squared. For the second part, I just take, but this time is a little bit tricky, because this one has negative and negative, so I'm going to take both negative 2, because they are both even number, 2 and 18. So I take 2 out of this, and m to the 3rd and m, so I'm going to take m out of this. So what's left? Negative 2m times this is going to be m squared, and negative 2m times 9. But do not forget, since you take negative 9 out of this, it's going to be positive, equal to 0. And so some students probably notice that they both have m squared plus 9. So I'm going to take m squared plus 9 out of this. And what's left is m squared, because m squared times this minus and 2m, right? Equal to 0. Again, you can actually to solve equation right now, or you can just continue factoring to see how much you can do. And the first two, you can see m squared minus 2m, they both have m, so I just take m out of this. And m squared plus 9, I'm going to use difference of perfect square as we did before, is separate this as m plus I, m3i equal to 0. So let's write down. So just remember, this is how do we do this. And the second part is coming from this one. So the first one, I separate this 2, and the second part, I separate this as 2. So 1, 2, 3, 4. We have 4 possible solutions. So m can be 0, 2, negative 3i, or positive 3i, right? So, but there's a side note for you to remind you again about this part. So I want to show you again. Again, some students prefer to solve this one, minus 9, that's also working. But do not forget, when you take the square root, do not forget it's positive and negative, because negative times negative is also positive. So it's going to be a negative 3i. So as you can see, this is exactly how we get positive and negative 3i here. Similar, right? So it really doesn't matter which way you want to use. Okay, so since this is the last method, well, I'm going to take a quick guide, take a quick several questions, and to guide our thinking about how do we factor for dealing with all different kinds of situations. So the first step you always want to try is GCF, because if you have GCF, always take them out, and then you will try, if you have 2 terms left, then try the difference of perfect square, or even try the difference of format of different square like this format. If you have 3 terms left, then you want to see if you have AM method working. And if you have 4 terms, then of course try the method we have today, factor by grouping. Again, always try the GCF first to see if it's working. Next part, you can just check how many terms you have, then try the different methods. It's always a combination of different methods together. Okay, that's all I want to share with you. Thank you so much for watching, and thank you so much for studying this topic with me. See you soon, everyone. Take care.